Hi everyone. Today we're going to study determinant of a matrix for the square matrix with orders 1 and 2. To every square matrix capital A equals the matrix with element A sub ij of order n. We can associate a number called determinant, and it's denoted by this symbol. Capital A is enclosed in two vertical line segments, or that of A. We go now to determinant of a matrix of order 1 by 1. Let capital A equals the matrix with element A sub ij be a square matrix of order 1. Then, the determinant of A is defined to be equal to A. Example, if matrix A equals the matrix 1 by 1 with element 7, then the determinant of matrix A equals that element 7. We go now to determinant of a matrix of order 2 by 2. Let matrix A equals with elements A sub 1 1, A sub 1 2, A sub 2 1, A sub 2 2 be the matrix of order 2. Then the determinant of A is defined as, so we have this symbol and is equal to, we will take the product of the elements of the main diagonal. So we have A sub 1 1 times A sub 2 2 minus the product of the elements of the other diagonal. That is A sub 2 1 times A sub 1 2. This is our formula. Example, if matrix A equals the elements 2, 4, negative 1, 5 respectively, then determinant of A is equal to, we copy the elements of the matrix, then we will multiply the 2 by 5. Minus, we multiply negative 1 by 4. Simplifying this, we have now this 2 times 5 equals 10 plus negative 1 times 4, and then the negative sign here becomes positive 4. So we have 10 plus 4 equals 14. This is the final answer. Today, we're going to study determinant of a matrix 3 by 3. Then we're going to discuss the expansion by minors method. This is now the expansion by minors method. Determinant of a matrix of order 3 can be determined by expressing it in terms of second-order determinants. This is known as expansion of a determinant along a row or a column. There are 6 ways of expanding a determinant of order 3, corresponding to each of 3 rows, R sub 1, R sub 2, and R sub 3, and 3 columns, C sub 1, C sub 2, and C sub 3, giving the same value. Suppose we have matrix capital A equals the elements A sub 1 1, A sub 1 2, A sub 1 3, A sub 2 1, A sub 2 2, A sub 2 3, A sub 3 1, A sub 3 2, A sub 3 3, respectively. The determinant of matrix A, and we will consider in this video expansion by first row. It will be like this. In the first group here, we have this A sub 1 1 multiplied by the determinant of the square matrix with elements A sub 2 2, A sub 2 3, A sub 3 2, A sub 3 3, respectively. Then minus the second group is now A sub 1 2 multiplied by the determinant of the square matrix with elements A sub 2 1, A sub 2 3, A sub 3 1, A sub 3 3, respectively. Plus, the third group here is the A sub 1 3 multiplied by the determinant of the matrix with elements A sub 2 1, A sub 2 2, A sub 3 1, A sub 3 2, respectively. This is our formula. For example, find determinant of A, where matrix A equals the elements 1, negative 2, 4, 1, 1, 13, negative 2, 6, negative 1, respectively. For our solution, we're going to find the determinant using this expansion by first row. Determinant of A now is equal to, the first group is this element 1 multiplied by the determinant of the square matrix 1, 13, 6, negative 1, respectively. Minus the second group will be negative 2 times the determinant of the square matrix 1, 13, negative 2, negative 1, respectively. Plus the element 4 multiplied by the determinant of the square matrix 1, 1, negative 2, 6, respectively. Then let us simplify the corresponding determinants. We have now this element 1 times the quantity negative 1, which is 1 times negative 1, minus 78, that comes from 6 times 13. Then minus the negative 2, it becomes positive 2, multiplied by the quantity, the product 1 times negative 1 is negative 1, minus the product negative 2 times 13, we have negative 26. Then plus the element 4 multiplied by the determinant. So we have this 1 times 6 is 6, minus the product of the elements negative 2 times 1, negative 2. So we have here 3 groups. We can simplify the first group into negative 79, plus the second group is simplified into positive 50, plus the third group is simplified into 32. The final answer now is 3. This is the determinant. Example 2. Find the possible values of y if determinant of this 3 by 3 matrix equals 10. The elements of this 3 by 3 are 1, 2, 0, 1, 2y, 3, y, 2, y, respectively. Let us copy this problem down here. Then we will use the expansion by minors along the first row. It will be like this. We will have 3 groups. The first group will be the element 1 multiplied by the determinant of this square matrix 2 by 2. 2y times y is 2y squared minus 2 times 3 is 6 minus the second group. Now we copy the element 2 and then we take the determinant of this 2 by 2 matrix. So 1 times y is y minus y times 3 is 3y plus the third group. We copy the 0 element, then the determinant of this 2 by 2 matrix. 1 times 2 is 2 minus y times 2y is 2y squared. Then this is equal to 10. Let us simplify now our equation. Look at the third group. Because of this 0, we can cancel the third group. Then let us simplify the two remaining groups. For the first group, 1 times the quantity 2y squared minus 6 becomes 2y squared minus 6 itself. Then the second group, y minus 3y is negative 2y. This negative 2y times negative 2 will be positive 4y equals 10. Let us put this 10 on the left side and combine with the minus 6. So we will have 2y squared plus 4y minus 16 equals 0. Look at our left side. We can see that the trinomial has a common factor which is 2. We can remove the common factor 2 to each of the term. So we can have y squared plus 2y minus 8 equals 0. We will factor out the left side. So we will have y plus 4 times the quantity y minus 2 equals 0. From here, we can get the values of y respectively. So we have y equals negative 4 and y equals 2. These are the values of y. Today, we're going to study determinant of a matrix 3 by 3 using diagonals method. The diagonals method is sometimes called Sarrus rule. Given this matrix 3 by 3 with corresponding elements, we're now using the Sarrus rule. Step 1 is we rewrite the first two columns of the matrix to the right of it. These are the first two columns, but we're going to write first the original matrix. Then the two first columns we will write somewhere here. Take note that there are three main diagonals here, and these are the diagonals. Also, there are three secondary diagonals. These are the diagonals in red. Step 2 is we will multiply the elements of diagonals respectively. Take note that the product of main diagonals are all positive, while the product of the secondary diagonals are negative. So for determinant of order 3 by 3, we will write first the products of the main diagonals respectively. So we have this a sub 1 1 times a sub 2 2 times a sub 3 3 plus the product a sub 1 2 times a sub 2 3 times a sub 3 1 plus the product a sub 1 3 times a sub 2 1 times a sub 3 2. And then we will write the products of secondary diagonals. Take note that we're going to use the negative signs. So this is now minus the product a sub 3 1 times a sub 2 2 times a sub 1 3 minus the product a sub 3 2 A sub 2, 3 times A sub 1, 1 minus the product A sub 3, 3 times A sub 2, 1 times A sub 1, 2. This is our working formula. Example, find determinant of A, where matrix A is given here using Sarrus rule. For our solution, first we are going to copy the same matrix down here. Then we identify the first two columns and we will copy these two columns on the right side, just like this. Then we will evaluate the determinant. So we have now the three main diagonals. We will take the products respectively. So this is equal to 2 times 3 times 4 plus the product 3 times 1 times 1 plus the product 4 times 4 times 2. Then the secondary diagonals. We will multiply respectively. So we have minus the product 1 times 3 times 4 minus the product 2 times 1 times 2 minus the product 4 times 4 times 3. We will simplify the products respectively. So we have now 24 plus 3 plus 32 minus 12 minus 4 minus 48. We can combine the positive numbers and the negative numbers respectively. So we have now 59 minus 64 and the final answer is negative 5. This is the determinant. Today, we're going to study properties of determinants. Let capital A be a n by n matrix. This is property number 1. Determinant of A is equal to determinant of A transpose. Property number 2. If two rows or columns of matrix A are same or proportional, then determinant of A equals 0. Number 3, if a row or column of A consists entirely of 0, then determinant of A equals 0. Number 4, if any two rows or columns of a determinant are interchanged, then the value of the determinant changes in sign. Number 5, if each element of a row or a column of a determinant is multiplied by a constant k, then its value gets multiplied by k. By this property, we can take out any common factor from any row or any column of a given determinant. Number 6, determinant of the product AB is equal to determinant of A times determinant of B. Number 7, determinant of A inverse is equal to the inverse of determinant of A. Number 8, if A is an upper triangular or lower triangular matrix, then determinant of A equals A sub 1, 1 times A sub 2, 2 times up to times A sub n. Property number 9. The determinant of this 3 by 3 matrix. First, let us analyze the elements. In the first row, the first element is A sub 1 plus K sub 1. Second element, B sub 1 plus K sub 2. Third element, C sub 1 plus K sub 3. In the second row, A sub 2, B sub 2, C sub 2. Third row, A sub 3, B sub 3, C sub 3. This is equal to the determinants of the two matrices. In the first matrix, we have A sub 1, B sub 1, C sub 1, A sub 2, B sub 2, C sub 2, A sub 3, B sub 3, C sub 3, respectively. In the second matrix, K sub 1, K sub 2, K sub 3, A sub 2, B sub 2, C sub 2, A sub 3, B sub 3, C sub 3. Today, we're going to study singular matrix. A square matrix A is said to be a singular matrix if determinant of A equals 0. Example, show that the matrix A is equal to, this is a 3 by 3 matrix with elements 2, 1, 5, negative 3, negative 1, 4, 6, 2, negative 8, respectively, is singular. We know that if A is singular, then determinant of A equals 0. So in here, we're going to show that determinant of A equals 0. We will copy the elements of the matrix down here, and then the first two columns we will copy on the right side. Then we will compute for the determinant. First, let us show the three main diagonals. We will find the product respectively. So we have this 2 times negative 1 times negative 8, that is positive 16, plus 1 times 4 times 6 is 24, plus 5 times negative 3 times 2 is negative 30. Then we consider the three secondary diagonals. The products will be like this. We have 6 times negative 1 times 5, and we write here minus negative 30. Next, 2 times 4 times 2, that is, we write here minus positive 16. Then minus the product negative 8, negative 3, positive 1 is positive 24. From here, we can simplify. As you can see, this positive 16 can be cancelled with negative 16. Positive 24 is cancelled out with negative 24. This negative 30 will be cancelled with this positive 30. So determinant of A equals 0. Therefore, matrix A is singular. I hope you learned something from this video. See you again next time.